STEPLESS. STEPLESS high-lift configurations for optimized aircraft energy management in the terminal maneuvering area, or TMA. Sustainability is one of aviation's biggest challenges today. To reach the EU's environmental goals, the aviation sector needs to continue improving the fuel efficiency of aircraft and taking measures to reduce noise exposure in the vicinity of airports. Aviation sustainability goals can only be met in a timely fashion if slower-moving technical developments are coupled with more immediate improvements of operational methods and procedures. In order to enable a low enough and therefore safe landing speed, aircraft are equipped with a high-lift system that generates additional lift at low speeds. For the deceleration phase during approach and descent, current high-lift systems feature only a set of a few fixed high-lift configurations. The ever-increasing traffic load that air traffic control needs to handle near busy airports often leads to ad hoc speed interventions. This forces pilots to select a higher configuration step earlier on, providing more drag, which in turn may lead to greater fuel burn and emissions. One operational means to improve the environmental footprint of aircraft during approach currently under investigation is the introduction of increased glide slope angles. Approaches with an increased glide slope angle are intended to reduce the noise exposure on the ground by allowing aircraft to fly the final approach at higher altitudes. Unfortunately, steeper approach angles also reduce the aircraft's capability to decelerate sufficiently during this flight phase. STEPLESS is a Horizon Europe project implemented in the framework of the joint undertaking known as the Single European Sky Air Traffic Management Research Project, or SESAR. In order to overcome the shortcomings stemming from the currently limited number of available aircraft configurations and to allow for more granular ones, STEPLESS introduces a novel high-lift system that enables automatic and stepless adjustments to aircraft configurations during approach. This allows dynamic adaptations of the high-lift system to glide slope angles and flight conditions, improving energy management and enabling steeper, more efficient glide paths. STEPLESS is aimed at energy-efficient approaches, investigating how STEPLESS high-lift configurations support energy-efficient approaches and analyzing potential reductions in CO2 emissions and noise. Pilot and aircraft performance, assessing impacts on pilots' workload, required interfaces and aircraft certification, as well as implications for departure and go-around phases. ATM adaptation, evaluating how stepless configurations can better integrate with ATM operations near airports. The project is expected to generate benefits for populations around airports by reducing noise exposure and improving air quality, airlines by reducing fuel consumption, and pilots by reducing workload without compromising the efficiency of air traffic management. The STEPLESS project brings together the expertise of 7 partners, from leading research institutions to large industrial groups and highly specialized SMEs from 3 EU countries and Switzerland. Follow us on cesarju.eu and LinkedIn.